say Gottfried Leibniz, weren't you the German mathematician who developed the present-day notation for the differential and integral calculus, though he never thought of the derivative as a limit?
Why, Newton, of course I was. Surely you know this. We worked together. Newton, the famous English physicist who was famous for his solutions to the contemporary problems in analytical geometry of drawing tangents to curves, differentiation, and defining areas bounded by curves, integration.
Why, Gottfried, of course I was. So do you know how our pals Pierre Fermat and George Riemann are?
Fermat contributed to the development of calculus through his work on the properties of curves. He found the areas bounded by these curves through a summation process. Now he thinks he is too good for us? Why, I ought to teach that punk a lesson.
Calm down, Gramps.
Who are you calling Gramps? You were 4 years older than me.
That doesn't matter because I still get more girls than you.
How disrespectful. This calls for a math battle.
Bring it on.
A wine cask has a radius at the top of 30 centimeters and a radius at the middle of 40 centimeters. The height of the cask is 1 meter. What is the volume of the cask in L, assuming that the shape of the sides is parabolic?
Such an easy question. It has a parabolic shape. Now just rotate it around the axis and plug it into the equation and you find the wine cask holds 425.2 liters.
You got lucky.
A printer need to make a poster that will have a total area of 202 and will have 1-inch margins on the sides, a 2-inch margin on the top and a 1.5-inch margin on the bottom. What dimensions will give the largest printed area?
A simple optimization problem. It is totally 18.7084 inches in height.
Damn, you're good.
What is one-way calculus is used in everyday life?
Economics. If C equals F, X is a function that relates cost, C, to X, the number of items sold, then both C and X can be considered to be functions of time. Thus, we can answer questions about the rate of change of cost with respect to time or about the rate at which the sales per unit time are changing depending on which items are known. The same model can be applied to profit, demand, supply, and revenue functions.
One of the more famous applications of calculus is its application in projecting a path of the Apollo capsule to arrive at the moon at the precise location in its orbit above the Earth. You can just point to the moon and fire. By the time you get there, the moon it has moved along at about 1/6 th of its orbit around the Earth. You have to factor in escape velocity to achieve escape of Earth's orbit with the minimum use of liquid fuel, and the precise combination of acceleration and velocity to get to the moon.
Examples of basic things that occur all the time in engineering are rates of change with respect to time, or space of such variables as heat, wave, gas, electric current, electromagnetic fields, conductivity of heat, current, etc. in various materials, vibrations in solids like bridges and buildings, and many others.
I would say we are evenly matched.
Agreed.
Oh, back to Riemann's, his work made mathematics more general or abstract. He put the definite integral on a firmer basis with a generalization now called the Riemann integral.
I always knew he would do good, seeing how he came a little less than 200 years after us.
Speaking of the future, have you heard of that 2011 graduate from Milton Hershey School? His name was Daniel Rodriguez.
Oh yes, I had heard of him. He is quite famous. He is an anesthesiologist and genetic engineer. He has studied not only in America, but in Japan and South Korea.
Sounds like he gets around.
He has also mastered the art of putting people to sleep and has found a way to genetically enhance a person's body. The one thing that has allowed him to reach such heights is a P-calculus.
A P-calculus isn't just a class, it also shapes the minds of the students. By taking the class you experience hardships and work on problem-solving abilities. It helps you deal with critical situations and teaches students how to find the answer when it is not directly there. All those lessons can be applied to real life. After graduation, many students find they need to be able to problem solve efficiently. They have to go through hard work and have to find the answer.
So by taking this class, it sets them up for the future. They can all be as successful as Dan. Man oh man. I wish I could get his autograph.
You and the rest of the world. He only gives autographs to K-pop groups. Oh, we should make our own.
We're mathematicians, not musicians.
Do it, do it. Chew, it's true, it's you, do it. Chew tilde algo sharpun ge mali immunanam geo ega I go nibiya hal jodo nam geo ya babe, ya bab emal subek bin sang sang armi eo jadario wati and juj, do it. Chew.
That was just terrible. You obviously wouldn't make it. You made someone die.
Oh well. Anyway, by having students find the answer and by going through all that hard work, they are set.
This was brought to you by, well, who else in your AP calculus class would do this? Truly, this is a Dan Rod production. It would have been better if the animation site I wanted to use wouldn't keep crashing the Flash player. Any questions?